We're looking at section T6 today. This is going to be over how to graph sine and cosine functions. And we're going to be looking at a lot of shifts. So we're going to be looking at vertical stretches. We're going to be looking at horizontal shrinks and stretches, shifts left and right, and up and down. So all those things together. So first of all, though, we need to get the basic 5 key points for sine. So here's where they come from. If you think of the unit circle, and right here this point is going to be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Well, we know that sine is just going to be y over r, and in the unit circle r is 1. So the sine is just going to be y. So at 0 degrees or 0 radians, we're going to have 0 as the answer for sine. At pi over 2 radians, our answer for sine is 1. At pi, it's 0. 3 pi over 2, it's negative 1. And at 2 pi, it's 0 again. These are called the 5 key points. 5 key points. If I ask for those for sine, that's what they are. Graphing this now, it's going to go 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. This is what we call a periodic function. The reason it's called periodic is because it continues on forever and it keeps repeating itself. So as far as you could go out, it would continue in the same pattern. So now we're going to look at the 5 key points for the cosine curve. So for the cosine curve, we think of our unit circle again, get those points. And now we're doing cosine, so we're looking at the x values. So going around the unit circle, tell me what the x values are. 1. And these are the 5 key points for cosine. And so graphing this, it goes 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. Okay, it goes like this forever. Another periodic function. All right, so we're going to now look at what happens if we have some changes. What happens if I put a 2 in front of the sine function? Well, I already have these into my calculator, so I didn't want to take time you guys having to type them in. So I just want you to look and see. I've got sine x in first one, 2 sine x in the second one. Any predictions as to what will happen when we put that 2 in front? Taller? Let's see. Okay, so I'm going to do, anytime I'm graphing, I want to check my mode, make sure I'm in radians. And the best thing to do next is a zoom trig. Zoom 7. So here's our original function. And here's our 2 sine x function. So you guys were right. This is what we call a vertical stretch. We don't necessarily want to say it gets taller because it gets also lower. So we want to call it a vertical stretch. If I want to check those points out, I can go to my table. Right now my table looks weird because I didn't set it up. So now I'm going to go to my second window and I'm going to set up my table. I'm starting my table at 0 and it's going up by pi over 2. And now I can compare these. So I can see that the points for the normal curve are 0, 1, 0, negative 1, 0. But for my second one now it's 0, 2, 0, negative 2, 0. And again, when you see this right here, that's just 0. The calculator gets a little confused sometimes, but that is negative 2 times 10 to the negative 13th. So it is 0. All right, so this again was a vertical stretch of 2, or by a factor of 2 if you want to say that. Anybody know what happens when we replace the x with a 2x? Shrink of what, vertical or horizontal? You are correct. And just to kind of get a look at that, I'm going to turn this one off. I'm going to turn this one on. I'm going to do my zoom trig, and just to see it, here's the normal sine curve, and here comes the new one, and we're going to see what this one is. And so this one ends up being just like that. I'm good for today. Just tell them I'm okay for today. Okay, so we've got this, and so now we're going to look at our, we could look at our table if we wanted to, but we can see that this was a horizontal shrink of 1/2. Horizontal shrink of 1/2. Okay, so on this one, anybody know what this is going to do? Left pi over 2. We're not going to check it. We know it's correct. And do you know what this is going to do? Up 2. Great. Okay, right here we have a summary of everything. I'm not going to go through these one by one because you guys seem to know what they are. But basically, we're just going to be making a chart of 5 key points based off of all of this. The only thing you may not have heard before is that if you want to find the period, you can always do 2 pi divided by b, and b is always just going to be that coefficient of x. If you want to find the b value, you can do 2 pi divided by the period, and that will also find b. And this is just something else you can use, but I don't typically use that. Alright, so we're going to be graphing y equals 3 sine of 2x. Here's the way I think it works best. Make your xy chart. We go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Our key points for sine are normally 0, 1, 0, negative 1, 0. But now we have this 2x. So x got replaced with 2x. So that means we're going to have a horizontal shrink of 1/2. So all of these x's are now going to have to get multiplied by 1/2. So those are going to be my new x values. For my y values, they're all going to get vertically stretched by 3. So that means I have to take my y's and I have to multiply them all by 3. And these would now be my key points that I graph. So at 0, I'm at 0. Pi over 4 is 3. Pi over 2 is 0. 3 pi over 4 is negative 3. And pi is 0. And we're just going to graph one period. So the period is now pi, and I could figure that out by doing 2 pi over b, and I can see that that was pi. Now, if I'm taking a test or something, it's a good idea to check this. So I'm going to go ahead and check it, and I'll show you what I'm doing here. I'm just going to put in 3 sine of 2x. I want to check my table of values, so I'm going to set my table. It's starting at 0, and it's going up by pi over 4. And so now when I check my table, I can see 0, 3, negative 3, 0, etc. So we know that we did this correctly. All right, let's go on over now, add a little bit more to it. We're going to do a cosine curve, and we're going to have some more things going on. So for cosine, we use 0, pi over 2, pi, 3 pi over 2, and 2 pi. Oops, 2 pi. For our y values, our key points for cosine go 1, 0, negative 1, 0, 1. We just need to know that. We're thinking of that unit circle. If we replace x with 1/2 x, what is that going to do to all of our x's? Multiply them by 2. So I multiply all of my x's by 2. Okay, what about, I've taken care of that. Now I need to look at this. I always want to use order of operations. So multiplication goes before addition. This affects my y's. So all of my y's are going to have to get multiplied by negative 1. So I've taken care of that negative. And now I want to take care of the plus 2. So I'm going to have to add 2 to all of my y values. And now just graphing, at 0 I'm going to be at 1. Pi is going to be 2. 2 pi is going to be 3. 3 pi is 2. And 4 pi is 1. And here would be 1 period of the function. So notice that the period should be 2 pi divided by 1/2. What is 2 pi divided by 1/2? 4 pi. Isn't that what this is? 4 pi? Yeah. If I wanted to check it, I'm just going to check one more here for you. Negative cosine of 1/2 x plus 2. I'm going to have to set up my table to start at 0 and to go up by pi. I can now check my values. 1, 2, 3, 2, 1. Yes, we're right. Okay. Now getting into a tough one. Lots of stuff going on. Let's go ahead and put our key points for cosine. It goes 0, pi over 2, pi. Just always put these down first, that's easiest. Cosine goes 1, 0, negative 1, 0, 1. Now go ahead and step by step take care of everything. So the 1/2, what's that going to do? Multiply the x's by 2. Okay, still working on the x's. Multiplication happens before addition, so I want to do that first. What is this going to do then? Shift it to the left. Pi over 2. And I can see a pattern developing now. So look, negative 1, 1, 3, this is going to be 5, 7. You should be able to do that quickly if you look for patterns as you're going. These are always evenly spaced, 5 points. So we took care of this. Now we go to this. This is a multiplier. That's going to multiply our y's because that affects the vertical stretches. So all of my y's have to get multiplied by negative 2. And then the last thing I have to do is subtract 3. And then just graphing it. And it should look like the cosine curve. And by the way, this right here, it has a special name. This is called the sinusoidal axis. And that's always just going to be equal to the shift. So this line is called the sinusoidal axis, and it's always going to be the same as that shift up or down. It goes right through the middle of the high and low points. So it's at y equals negative 3 for this one. It was at y equals 2 for this one. Okay. All right, now for going in the other direction. Sometimes this is difficult for people. Find the equation of the curve passing through the points that are given. I like to write them in table form. So we have x and y, 0, 0, pi negative 4, 2 pi 0, 3 pi 4, 4 pi 0. Now, looking back here, do you notice how when we had cosine, the second and fourth were always the same? Here's another cosine. The second and fourth y values were the same. What about for sine though? Which ones were the same for sine? Yeah, the first, third, and fifth. Okay, so that's going to help us. So, for the y values, when the second and fourth are the same, it's going to be cosine. When the first, third, and fifth are the same, it's going to be sine. So looking at this one, which ones are the same? So what's it going to have to be? Sine. So I know it's going to be y equals sine. Okay? But I have to figure out everything else. This should go 0, 1, 0, negative 1, 0. And it's not. So I have to figure out, did these zeros get moved up or down? No, they're still zeros. So there was no shift up or down. But what happened to these y's as to what they should have been? By not just 4, but negative 4. So I had to have an a value of negative 4. All right, now what about these b values? They were supposed to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So what happened to them? They got multiplied by 2, so I'm not going to have a 2 in here, though. What am I going to have? 1/2. And that would be the equation. And if I am taking the test and I want to make sure I have this right, I would just go ahead and check these key points. I'm going to go to my table setup. I'm going to start at 0, go up by pi, check that table, 0, -4, 0, -4, that's a 0. Good, we got it. Okay? All right, last one here. Again, it's just habit for me writing it here in a table form. You don't have to. Okay, so looking at which ones are the same. Which ones are the same? So what's it going to have to be then? Cosine. And at least we know it's cosine for now. We've got that much of it figured out. Okay, now we're going to have to look at this. Cosine is supposed to go 1, 0, -1, 0, 1. These are supposed to be zeros, and they're not. So what do I know about the graph? It had to have been what? Moved up 1. So I know it has to have a +1 at the end. Now, these are supposed to be having a difference of 2. So from this sinusoidal axis to that point, it should be 1, but it's not. So what must these have gotten multiplied by? Like, what's the difference from here to here and here to here? 2. So it's twice the amplitude that it should be, amplitude meaning the height from the sinusoidal axis. So this is 2. Now the other thing I want to point out to you is that these are supposed to go 1, 0, -1. So they're supposed to go down. These do go down, so we're good. But what if they had gone up? What would that tell me then? That I would need to have a negative, yeah. Okay, now to me this last part is the most complicated, because we know that it can't just be x, can it? Because it should go 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's what it's supposed to do. So what did these get multiplied by? Like, how do I go from pi over 2 to 1? What would I have to multiply that by? 2 over pi is what it got multiplied by. Let's see, does that work for this one? Yeah. For this one? Yeah, it works for all of them. But if they got multiplied by 2 over pi, what does that mean was actually in front of the x? 1/2 pi, right, or pi over 2. Now, that's right, it's pi over 2x. I think this is complicated though. What I do is I go back, I like to use this right here, that b is always going to be 2 pi divided by the period. So if I want to find this b value, I can say b is going to equal 2 pi divided by, what's the period here? How long before it starts over again? 4, right? 0 to 4 is 4. So b has to be 2 pi over 4, and so what does b have to be? Pi over 2, which is what we had. I like this because sometimes with this, when I think I have to multiply this by 2 over pi, I tend to want to put 2 over pi there. But it's not. It's always the reciprocal, because that's how we did this. Remember? Like, even though this got multiplied by 2, we put a 1/2 there. See what I mean? All right, questions on that? Okay, well that's all we've got for today. You guys are going to do worksheet T6 on your Canvas.